Welcome! Today we're going to break down some really cool research that's tackling a massive challenge. How do you teach an AI to understand a language spoken by millions of people, especially when that language has been kind of left behind in the digital age?
All right, so let's get right to the heart of it. The big question these researchers were asking is, how in the world do you get an AI to learn a language spoken by millions when there's barely any digital stuff for it to learn from? This is a classic problem in the world of AI, and it's a super important one to solve. So to really get what's going on, we need to talk about this term low-resource language. All it means is a language that doesn't have a lot of the digital data that AI needs to train itself. Things like huge text databases or ready-made software tools. Without all that raw material, it's incredibly tough for a machine to learn all the little details and quirks of a language.
And that brings us perfectly to the star of our show today, the Sinhala language.
And listen, we're not talking about some obscure dialect here. There are about 20 million people who speak Sinhala. The research breaks it down to roughly 16 million native speakers and another 4 million who use it as a second language. So yeah, it's a major language for a huge number of people.
So here's the crazy part, the real paradox. You've got millions and millions of speakers, but the technology to actually process and understand the Sinhala language is, well, it's way behind. This creates this massive digital gap, leaving all those people kind of disconnected from a lot of modern tech.
So how do you fix a problem that big? Well, these researchers came up with a really clever hybrid solution. Basically, they decided to combine the strengths of different AI models.
And the secret sauce is right here in this quote from their paper. They didn't just grab one AI and hope for the best. Nope. They built what they call a novel hybrid approach. They put together a team, a super specialized model called the Spacy CNN, and a big, powerful general-purpose one, LLaMA-3.1-Sonar.
And this slide really shows you why they did that. It's like hiring two different experts for a job. The Spacy model is like a surgeon. It's incredibly precise and amazing at spotting very specific details, like names of places. LLaMA, on the other hand, is more like a seasoned detective with a deep understanding of context, giving really solid performance across all sorts of different tasks.
Okay, so you've got this AI dream team, but how does it actually do its job? Let's break it down. You can think of the whole system like a super smart AI librarian who's been given the chaotic job of organizing a massive library of news articles written in Sinhala.
The process is actually pretty straightforward and elegant. First, it reads through everything and spots the important keywords, people's names, places, events. The technical term for this is named entity recognition. Then, step 2, it starts grouping together all the articles that are talking about similar things. That's the clustering part. And finally, for each of those groups, it creates a simple, smart, bilingual label, so a person can look at it and know exactly what's in that stack.
And they used a really cool trick for that grouping step. Instead of what's called hard clustering, where every document has to go into one and only one box, they used something called fuzzy clustering. This is brilliant, because think about it. A single news story can be about politics and the economy and culture all at the same time. Fuzzy clustering gets that. It lets a document belong to a few different categories, which is way more like how the real world actually works.
The level of detail here is also pretty amazing. The system wasn't just trained to find a name or a city. The researchers actually taught it to understand the type of event it was seeing. Is this a political event, a sports event, an economic one? This gives the AI a much, much deeper understanding of the text.
Okay, so we've got this really sophisticated, custom-built system. But here comes the million-dollar question. Did it actually work? Let's check out the results.
Okay, so let's look at the proof. How well did it actually find the important stuff? We're looking at a score called recall, which is just a fancy way of saying, did it find everything it was supposed to find? So look at this. On their own, the models did all right. Spacy hit 50%, LLaMA got up to about 67%. But when you put them together, whoa, a massive leap to 91.7%. That's not just a small improvement, that's a game changer. It shows that putting these two together was absolutely the right move. But finding the info is only part of the job, right? Could the AI actually create labels for the groups that a human could understand? Well, they had human experts rate the AI's labels, and look at these scores. They were consistently high for accuracy, for specificity, and for clarity. This means the labels weren't just computer-generated nonsense, they were genuinely useful.
Now this looks a little technical, but don't worry about the names. All you need to know is that these numbers measure how good the groups themselves are. Are they well-defined? Do they make sense? And these scores are strong. They're the mathematical proof that the AI was creating really distinct and meaningful clusters of documents, not just random piles.
So, okay, it works like a charm for Sinhala. That's awesome. But now let's zoom out and talk about the bigger picture, because the real impact of this goes way beyond just one language.
And this is why this whole thing is so important. What they've built here isn't just a fix for one language. No way. It's a blueprint. It's like they've drawn a map that other researchers can now follow to bring hundreds, literally hundreds, of other low-resource languages into the digital world. You remember that digital gap we mentioned? This is how you start to close it.
So let's wrap it all up. What are the big things to remember? First, teaming up different AI models is way better than just using one. Second, for messy, real-world text, fuzzy clustering is the way to go. Third, we've seen solid proof that an AI can generate labels that are actually useful to people. And maybe the most important takeaway of all, this whole approach gives us a real path forward for bringing underserved languages into the modern age.
And that leaves us with one last big idea to chew on. This kind of tech isn't just about sorting articles, it's about giving people access to information. So you have to wonder, what other knowledge, what incredible stories and ideas are currently locked away in all the world's diverse languages that a technology like this could finally help us all unlock? It's a pretty powerful thought.